Hello, everybody. Thank you for coming to Hack Club's Ask Me Anything with Jared Isaacman. I'm Meghna.
I'm Will.
A little bit of Hack Club and who we are. Hack Club is this global charity that serves teenagers all around the world from ages 13 to 18 and helps them build technical projects and just become more technical and be the kind of engineer that hopefully Jared will want to see when they're someday working for NASA. We teach people how to code, how to make PCBs, which are like the little green things in computers. And all you have to do is if you're interested in building something cool, go to hackclub.com or go to stardance.hackclub.com and sign up. And you can learn how to make cool websites and you can learn how to make cool programs and cool PCBs and meet 100,000 teenagers who love engineering just as much as you do.
Yeah, this call is made possible by the Stardance program, where if you log your hours as a 13 to 18-year-old, you will get free prizes and we'll fund your hardware projects. And we're trying to get as many kids building this summer as possible. My name's Will. I make social media videos. I post them on Instagram and YouTube to get as many kids to know about Hack Club as possible. And then I also build hardware projects and I post them online under the name Will's Builds.
And I'm Meghna. I'm 17 and I'm from Ohio. I started coding about like 2 years ago when I started going to local hackathons. And actually, one of my first hackathons was the NASA Space Apps Challenge in Cleveland at the NASA Glenn Research Center. And that's where I learned that I could actually make things that other people can see and like deploy it on the internet and make it real. And from there, I've just never stopped building projects that I care about and building things and keep engineering, and learning stuff, even though I'm bad at it, because I'm always learning. And
We are.
so and so, yeah, Jared, thank you so much for joining us. We appreciate it more than you could ever imagine. I'll let obviously him introduce himself properly, but to start off, a little bit about him. He dropped out of school when he was 16 to found a payment processing company in his parents' basement that businesses all around the world use today. He has over 8,000 flight hours in both military and civilian aircraft, and he also circumnavigated the whole world in a Cessna Citation in 62 hours. Now, he's the 15th administrator of NASA and is working to bring humans back to the moon, hopefully using nuclear power.
Yeah. Well, going to Mars for nuclear power, but
Right, yes.
it's absolutely awesome to be here right now. And did drop out of school at 16. I did wind up getting my college degree later on. So let's keep everybody remain on the well proven road of higher
I think I'm gonna go drop
education.
out right now,
But
Jared.
Actually, I'm
but
taking so much inspiration from you.
Yeah.
but I would also say please also keep that in mind and calibrate your questions accordingly when they during the Ask Me Anything. It's awesome to be here. Great. Like we what an exciting time over the next couple decades, especially as all of you guys who are, doing the good coding and engineering projects right now are going to wind up graduating into a time when we're building a moon base and we're building nuclear powered spaceships. And we're going to need so much talent in order to make any of these near impossible objectives and bring them into reality. So it's absolutely time incredibly well spent being here with you all right now, and hopefully getting you interested in career paths ahead in industry and at NASA.
That's awesome. Will, do
Yeah,
you want to
totally.
start us off?
Yeah, I'll start with a question. So I'm just curious, as someone that builds hardware projects, right? A lot of the the products that NASA makes, right? The shuttles and everything they do requires a lot of electronics, designed electronics. And I'm curious as to where you get the parts for, the electronics that you produce. Like when I make something, I go to DigiKey and I search for a while and I find the piece that I need. If it's like a microcontroller or even just jelly bean components like resistors and capacitors, I go to DigiKey and then I order it and it shows up at my house. But like I can't imagine NASA doing that. You know what I mean? But like then I wonder, where does NASA get all of their parts? Because most small electronic components are produced out of the US. You know what I mean? And so outside of the US. So I'm wondering, like, where does NASA get their components for electronics boards? And what are the implications there, like security implications or like verification of like the specifications, like that it can actually do what it says it can do, or what it means for something to be space grade? Where do we get our stuff when we build um electronics for shuttles?
Well, there's a lot to that. Let's start out by saying just about everything that we intentionally try and buy something from every congressional district. How about that? So they somewhat of a. It's late in the day, so I'm going to bring some of the humor out here if you don't mind. But I mean, look, the simple reality when you take something like SLS, you have five prime contractors on it, quite literally hundreds of subcontractors, and yes, they were all procuring to either. They're all procuring components that are either flight qualified previously, which case a lot of SLS, quite honestly is, because quite a bit of it is repurposed from the shuttle era. Or we go through an extensive qualification process, of which NASA, we have unbelievable test chambers. A lot of them are actually national historic landmarks because they've been around for so long. But quite literally, TVAC chambers that we have. We use chambers for different flammability testing, vibe tables. Stuff that goes back decades, but we still use today to qualify our hardware for integration into, whether it's uncrewed robotic spacecraft, but it's a flagship level, as in cannot fail. So we want to test it extensively, or it's a crewed vehicle, of which you have the whole human rating qualifications that are associated with it. We are very cognizant of the cybersecurity type implications. So aside from we want to build really good spacecraft that are that help us achieve the correct outcome for our mission, whether it's keeping our astronauts safe so they can undertake their mission, or to go out and explore the secrets of the universe. But there is, secondary considerations in all of this is going to be the security of our infrastructure to be able to communicate and command back and forth the vehicle, and then the electronics themselves for intrusion or other, considerations beyond just meeting its initial mission design criteria. And then we do, there are certain laws that prevent us from working with, certain countries, whether it's collaboratively as individuals or from a procurement of hardware perspective. And if you need to deviate from that, there's a rather lengthy waiver process. But then some of it is actually quite by design. So the European Service Module that's attached to Orion as part of the SLS architecture, for example, most of it is made in Europe and has suppliers from actually just about all of their ESA member states in it. So there still can be foreign components in our architecture, so long as it's part of design and meets our qualification criteria.
That's cool. That's awesome. I think that's something that I've been working. Because all of us are teen engineers, right? We've all, made PCBs before, and have our, orders canceled by DigiKey, and going out and sourcing all of our parts is a big deal. And I'm sure that doesn't change even when you scale it to a national level or an international level, right? So that's really cool. I had a question. 8,000 hours spent in the sky means a lot of time spent in a lot of different planes. What would you say is the biggest difference between flying military jets like MiGs versus civilian aircraft like Cessnas?
Yeah, it's just the speed at which things happen, which just compresses your decision space a lot. And look, it's very applicable, in space too. So you think about a Cessna 172 or something, where things are happening at, 50 or 60, or 70 knots, for example. You have some time to sort things out. And when things are happening, you take off and land an F5 at 160 knots. Same with a MiG-29. So when something goes wrong, you have less time, to sort out how you're gonna potentially solve the problem. In aviation, we train an awful lot to never get behind the aircraft. Well, that's a lot of what astronauts do to train to go to space, is to be very cool under incredibly stressful situations, and assess the situation as quickly as they can and make decisions that generally come down in seconds. Because you think about the time when you launch a Falcon 9 or ignite the solid rocket boosters on an SLS, to the time you're in orbit, that's happening in minutes, right? And when something develops, it can develop in, obviously even, nanoseconds.
Yeah.
Jeez.
Would you rather do a barrel roll in a MiG or a Cessna?
Oh, a MiG for sure. That's not a statement on an endorsement of the country of origin or the manufacturer, but simply that you can fly faster and you're more maneuverable and pull more G's in a MiG than you can in a Cessna. Not to mention, I would say structurally, I would feel a lot better about the plane designed to take 9 G's than probably one designed to take 3.
That's and awesome. You just look cooler.
Yeah, it looks, which is the first rule in aviation, by the way.
Oh yeah,
right.
For sure.
Exactly.
It's that's what they teach you in Top Gun, right? That's the point of Top Gun, was to look cool.
Well, no, and all things aerospace generally, it's first rule, look good. Second rule, sound good on the radio. Third rule, try and be safe.
Exactly. Yeah. Facts.
Nice.
Do you have a second question?
Yeah. I'm curious. So I understand that the SR Freedom 1 is a mission that's coming out. I believe it's set to launch 2 years from now, right?
Yeah.
that involves nuclear propulsion, which is something that has been researched before, but is something that we would be doing for the first time in 2 years with SR Freedom 1. And I guess I'm just curious. I'm sure you're going to get a lot of like people from the public nervous about launching something nuclear. You know what I mean? Given that if something goes wrong, there's probably a sentiment that there could be some kind of fallout or just like radioactive material in the air. And I'm wondering like what you do when you're engineering a spacecraft that contains radioactive material that's to be launched to space. What do you do to ensure that even if it does fail, it's kind of contained to just that spacecraft?
Yeah. So I have to say up front, I'm actually very pleasantly surprised that there is, I don't even want to say minimal. There's just generally been no pushback to the reality that we actually have 3 nuclear payloads that will be going through Kennedy Space Center in the summer and fall of 2028. So you have the Rosalind Franklin rover. It's actually a joint NASA ESA mission that's going to have a plutonium-based roux on it for heating. You've got Dragonfly, so that's your RTG, plutonium-powered octocopter going to Titan, and then you've got a real fission reactor, which is awesome. That's going to launch on SR1 Freedom. And I would just say that I think maybe perhaps, some of it's been the repetition. You have a SpaceX launching every 48 hours and, their batting average is extremely good. SR1 Freedom, Rosalind Franklin, and Dragonfly, I think all 3 are going to launch on Falcon Heavy. So, you have an extremely reliable, competent partner that you're going to be working with on this. So I think that diminished some of the public's concern. I mean, look, it was very different 15 years ago. You saw a rocket like every quarter. And you're like, it still seems a little bit, are we putting a rocket with nuclear material in it? And then also the materials. The materials, like, for example, in the fission reactor, we're going to use a very safe fuel that has, basically it's got a ceramic coating around the uranium pellets, which is a very low enriched uranium too. That's designed to, survive or be not, in a almost a catastrophic type situation that could happen in a reactor. So, I think it's also not obvious to be, state the obvious. It's not critical on the launch pad. Like we are going to launch SR1 Freedom. We are going to send in on a Earth's escape trajectory. So it's going to Mars. Period. Whether the reactor turns on or not, it's gone. So not our problem anymore. And then we activate and the reactor will go critical and we will shift some of the propulsion from its solar panels and start using a Brayton cycle conversion and take the 100 kilowatt fission reactor and turn into about 25 kilowatts of power to basically the Hall thrusters that are already integrated in the vehicle. So it's gone no matter what. It's not going critical until it's already clear it's not going to be Earth's problem anymore. But what a step in the direction we must take. I mean, it's great that, industry and SpaceX and Blue Origin, pushing the boundaries in chemical propulsion and then helping us not throw away the rocket every damn time we have to use it. I mean, these are all such important breakthroughs for everything you can imagine in the future, like on-orbit assembly and manufacturing and building moon bases and science missions and space economy and space stations, all that. But if we really want to get out there, in the outer solar system and explore our outer moons, and certainly I think be able to send astronauts to Mars and bring them back without the firm requirement of manufacturing propellant on Mars and refueling to come back home, we got to do more with nuclear. And we've just spent way too damn long for such an obvious evolution, especially now that commercial industry is doing so well.
That's really awesome. Yeah, that's really great. Okay, our first question from the audience is from Sam, who's 17 and from Oxford, England. Sam?
Hello, can you hear me?
Yes, we
Loud
can.
and clear.
All right, perfect. I was just wondering, when you were around our age, so around 17-ish, do you think like what you're doing with your life now is what you'd be doing, like working with NASA, working with space and everything? And was there something you were passionate about that you decided to leave behind?
No, there was zero chance I could ever have imagined this. I mean, quite honestly, where I was, when I left high school at 16 to start a company, I was simply, I was raised to be extremely independent. If I wanted anything, I had to work for it. I'm, grateful for my parents instilling that kind of work ethic in at a young age. So simply, I wanted to move out. I needed to pay rent. I wanted to be able to get, pizza and beer on weekends. That was my motivation. And I was lucky that I stumbled across, an emerging payments field. I mean, this was at the time where e-commerce was just, again, it was emerging. Like, the idea of buying something on the internet in 1999 was very different than what it is today. So there was a problem to solve or build a better solution to an existing problem. And, that was my motivation from day one. Now, aviation has been a passion since I was quite literally in kindergarten. I mean, I told my kindergarten teacher I wanted to be an astronaut someday. I went to space camp. I built my first computer to play flight simulators. So that kind of passion was always there. But my motivation was very different then. Even when I was 21, again, I could not have imagined when I was 16 that something that I started to just, maintain a very basic, normal lifestyle would have evolved into what it was by the time I was 21, let alone everything that came thereafter. And that's the luck in life. People are like, you make all your own luck. It's like total BS, right? Like you got to work really hard and find your passion and try and solve good problems and stand out and elevate yourself, so that you can, or differentiate so you can, take on new opportunities that come in life. But having the ball bounce your way a few times in life never hurts. And that's why I'm doing this job, by the way. Like I absolutely live the American dream. I know I got lucky many times over. That's why I'm so grateful to have an opportunity to repay the debt to the nation and get to do it in the coolest job in all of government, which is NASA.
Oops, we got a whiteboard.
Oh,
yeah.
We're good.
Okay,
Okay.
we're good.
Oh, that's so interesting. Thank you.
That's awesome.
Yeah, no, that is sick. I think our next question is from Vuk, who we actually saw his project. And Vuk, you should show Jared Jared your project just real quick before you ask your question, because it is really cool.
Hi. So over the spring, I made this 3D LiDAR scanner. It's able to do 3D scans of the room it's in, up to 250 points a second. I also wrote custom visualizer software and made a custom PCB for it. And I was wondering, does NASA currently use LiDAR for, terrain mapping or landing? And are there plans to use it for other use cases in the future?
Yeah, I mean, it's certainly, first of all, by the way, I don't know what your next couple of years are looking like, but if you're building this capability and developing the software for it, you should really look at some of the NASA internship programs. We need all the talent we can get. We're trying to do really hard things these days. So LiDAR is certainly part of some of our rendezvous and docking constructs, and we are also looking at it for lunar surface applications as well. So it's and I guarantee whatever approach we take to building our hardware will cost many orders of magnitude greater than what you probably spent doing it, and it'll take a lot of geniuses around here, but hopefully we'll eventually get it to the performance level that you've already mastered.
Well, that's really cool.
Yeah, that is sick. I believe we're trying to pull up the next question.
I'll take the next one if we don't have one pulled up. A year ago, I built a payload that was launched onto a high altitude balloon and collected a bunch of environmental data, magnetic field sensors and pressure. NASA has done similar missions with the PACE and Parker Solar Probe. I've always wondered, how does data from those unmanned satellite missions help NASA in the future?
Well, the answer, they do. I mean, like all of you, we're always hungry for the data. I would say where we can improve upon is how quickly we take that data and use it to inform the subsequent mission. So for example, I loved Parker Solar Probe mission, but I mean, it is also the fastest man-made object ever, I think. So that in itself is something that's cool, and I don't believe generally widely known. But we, a lot of our high priority science missions are informed by the decadal survey process. Kind of you think makes a lot of sense in decades past when launch costs were, $500 million or more, and you want to take an awful lot of time to think through what your next mission would be and get consensus, because it is generally hard to make everyone happy in this regard. But now launch costs have come down so much, and you are able to get data very quickly, and you're able to analyze it very fast. I mean, one of our two priorities for it's a presidential mission, the Genesis mission, where how do we do a whole government approach with AI to accelerate all the most important kind of scientific or forward-leaning tech arms of U.S. government. And instead of everybody doing their own thing, concentrate your resources into a team that's extremely good. DOE, no secret, has had some pretty sophisticated high-performance computing power for a very long time. So it's kind of one of their core competencies. In any case, two priorities from NASA. Number one is like, what did we miss, and what are we likely to miss? So not that long ago, an intern, not an intern, like a high school, student found a missing galaxy just from NASA archival data. Now there's 2 trillion of them out there, so you can't fault us for missing one every now and then. But that's based on historic archival data. We're about to get so much more of it through new exploration assets like Nancy Grace Roman Space Telescope is going to gather so much potential data that's going to be out there. So all of the data that we've accumulated and all that we are likely to accumulate, how do we use AI kind of to our advantage in that? And then second is helping us design the next generation, again, fission power, fusion power type spacecraft to extend our reach a little bit farther into space. I say all this to say, like, we get lots of data and we don't move as fast as we should on it. Like you should not have to wait 10 years or so to get, once you have the data and it's sufficiently analyzed to reach a consensus on what you should do next. You should gather that data from like Parker Solar Probe, just like your balloon example, and say, I learned something new. Now, what do I want to do with that knowledge? And roll it right into the next mission. Industry is very good at this, right? SpaceX very good with their design process. We need to be much better at it.
Gotcha. Well, actually, the balloon that I launched fell into a tree, and that data was unrecoverable. But I completely get your point. And yeah, I totally agree. I think that's really interesting.
Data was not used very quickly, for sure.
Yeah.
No, it wasn't.
All right, we have our next question from Frog, who's in Portugal. There we go.
Frog, if you want to go ahead.
Why was it decided to fly Artemis 2 with astronauts on board when many experts such as Charles Camareda concluded that the solution for the charring issues on the Orion capsule heat shield was not sufficient enough to give confidence that it was safe to fly?
Well, I think on a lot of matters that are complicated and you haven't, it's very hard to get a universal consensus. What I'd say is, Charlie and a few others were certainly in the minority. There were, a few thousand really brilliant minds at NASA that had done a lot of work, including using ArcJet, to gain confidence that we had mitigated the heat shield issues by virtue of a modified reentry profile. And they were right. And Charlie was wrong. Now, there's nothing wrong, by the way, of having some, dissenting voices at times, and you should listen to them all. And I did. I brought Charlie in and others, along with some journalists and all of the NASA experts, to have a roundtable, right? And say, let's get it all out on the table, because he might not know everything. He certainly didn't. He hasn't been at NASA in a long time. And you have a lot of people working every day doing the work and doing testing and analysis to arrive at the right position. So you brought everyone in the room to share their thoughts on the subject. Now, there were 2 dissenting voices in the room. Charlie was one of them. The other, another former NASA astronaut, changed his mind, agreed with our position. And Charlie, again, he obviously, stuck to his guns on that and felt that he was right. But in the end, he was wrong. And nothing was wrong with our process, though, to analyze the matter, test it, which we did extensively with ArcJet, which is a very cool facility inside NASA. And then we listened. Like I said, we're not dismissive. I brought Charlie in and others to have the conversation. And some people in the room liked the conversation. Charlie did not. In the end, we felt we had sufficient data and understood the risk to fly the mission. And the heat shield was perfect.
Yeah, I think that's a fascinating, philosophical question too, is what is, and forgive me, because I don't know a lot about this, but what's the failure rate? Because it's not going to be a 0% failure rate ever on anything. What's the failure rate that you are willing to accept when you're putting human lives on board on something? Is there an industry rule of thumb for that kind of thing?
Yeah, of course. And obviously this is something that NASA, unfortunately knows an awful lot about, because we've had some extraordinary highs and we've had some very sad days at our space agency, right? From Apollo 1, Challenger, Columbia, and I would say, look, we do probabilistic risk assessments on everything, and then we take an integrated view of the risk, and then we understand it. We try and do everything we can to mitigate it, and at some point, you do have to accept it. Because, look, taking off an airplane on an aircraft carrier is dangerous. Flying in a helicopter, is dangerous. There are a lot of jobs that we knowingly send people into, working, under the sea by a couple hundred feet in saturation diving on oil rig. These are all dangerous jobs, and you do what you can to bring it to zero. But at some point, you do accept and move forward. Why would we think exploring the worlds beyond ours would be any different? It's very dangerous work. Now, I will say, like, what I would take away from this, again, I think the NASA team did the right thing, clearly analyzing the situation with that heat shield. But the question is, you got to rewind the clock and say, how did we get in that position in the first place? Like, we built a non-permeable heat shield, which was a departure from the 1960s Apollo program. So we forgot something. And ultimately, we had to take the data that we had and, again, fully understand the situation, test it, and we did work up a modification of the reentry profile, and it worked exactly as predicted. And now Artemis 3's heat shield will return to the original permeable design that we used during the Apollo era. But how did we wind up in that situation? Well, let's never do that again. It's one of my first priorities here. My first workforce directive, actually, is say, why did we outsource so much of the talent at NASA that should be a core competency? That should be inherent within the organization. 75% of our workforce became contractors over the years. And you can't do that. You can't do that to win the space race of today or tomorrow or to deliver on the mission of all the taxpayers who fund our work here at NASA. So we've been bringing thousands of people back into the organization here at NASA in areas that we can't afford to make mistakes on in the future. So we did everything we could to on the Artemis 2 heat shield the right way, including listening to those dissenting voices and giving them a platform to have the conversation. We understood the risk. We did everything we could to mitigate it through operational design. And then we flew the mission. And then what was predicted versus actual on it lined up, as close to perfectly as you could get in this kind of circumstance.
Yeah, I think that's super interesting, and it raises a ton of like moral questions that Will highlighted. Our next question is actually, Will, if you want to say it.
Oh, Adi from Phoenix, Arizona,
Which is Will's hometown.
my hometown.
Yo, I'm Addy. I'm 15 from Phoenix. My question is, if you were 15 today, what would you spend the next 5 years building?
That's a good question. Oh, and also, Jared, if I might add, we're gonna go through like a really quick lightning round. So if you could like answer this questions in like maybe 30 seconds to a minute, we want to get like as many as we can in.
Oh, okay. Copy that. What would I spend time building? I don't know. I think I'd be spending more time studying. Like, honestly, there are so many things I've been exposed to, especially in my new job here in fields of study that I just find so fascinating. And I wish I had started on earlier in life. I have no regrets on my path been taken, but like, there's just so many areas of great interest. So I don't know. I'd be studying a lot in quantum right now. A lot of things in space medicine, by the way. Anyone who wants future careers in space, believe me, the technology is going to outpace the ability for the human physiologically and psychologically to be in deep space. There's a lot of things I just would probably try and get smarter on before I selected my ultimate career field. So sorry, it's not a build answer, but it's just a knowledge gather one.
I'll add a lightning question. What is the most fascinating space medicine fact that you know?
100% of people will feel very differently in space, period.
Wow, that's so insightful.
Yeah, I mean, it's something that we've protected for a long time because it's like challenges the hero image to some extent. I mean, your best case scenario, 40% of the people you feel like you're hanging upside down for like 3 to 5 days, and you have worst case is you're throwing up for 5 days. You have vision issues. It's all probably related to intracranial pressure that's increased, and it's been that way since the beginning, and we just don't talk about it much.
That's
wow,
crazy.
That's insane. That's crazy. All right. Our next question is from Kieran Klukas, who's actually from my hometown of Columbus, Ohio.
We got you unmuted. There we go.
All right. Hi. My name's Kieran Klukas. I'm 18 and I'm from Columbus, Ohio. And so I built this project this summer. It's a combat robot. It spins at about 3,000 to 4,000 RPM and then actually uses a custom IMU array that I designed based off of a older NASA white paper on using IMUs to detect rotation in space capsules, which is very cool.
Yes. Kieran, show us the other side. We only saw the bottom.
Oh yeah. So it's very messy right now. I took it to open source, and so the wiring is a little bit chaotic now.
Looks good to me.
Thank you. My question is, because NASA's budget today is about a third of what it used to be during the peak of the Apollo program, And you're proposing to run both a Mars mission and a Moon mission in parallel with each other. And we're also running new programs like the SR1. Do you think that moving faster, like commercial companies like SpaceX, will help overcome those budget challenges? And do you think that because we now have lower launch costs, that will also help?
Yeah, all of that's yes. Everything you've got is right. The only thing I just say, look, I mean, and correct my math if I'm wrong on this one, but I think, not to nitpick, we get 25 billion a year. I think peak. That's not counting the $10 billion plus up we got from the Working Family Tax Cut Act. But, I think if you go back to peak 1969, you're probably adjusted for inflation in the high 40s or so. So either way, the point being we are a smaller percentage of the discretionary budget today than we were then. But what's changed? Yeah, nothing existed then. I mean, heck, our first vehicles were all ICBMs. Like we had to borrow stuff from the Department of Defense, Department of War. We have industry to draw upon now. NASA is one customer of many in launch. You got Falcon 9s for Starlinks. You got Falcon 9s for NASA and scientific missions, for DOW missions, for commercial satellites. So cost has come down materially to put mass in orbit, which is great. It helps. And then I will tell you, the private investment coming from, a Elon Musk or a Jeff Bezos and such is well in excess of the government contracts. Like HLS, believe me, you guys know, I mean, they just raised $100 billion for this effort. They're putting in 10x whatever the taxpayers are putting in. So that's all enabling. The issue is not a top line at NASA. I mean, look, I would always say, like, I'd love for us to be so dialed in that we could do more with more. But the reality is, for the longest time, absent global competition, we've been spreading money around everywhere and not concentrating our resources on what you expect of us. More missions like Artemis 2, building a moon base, nuclear powered missions, more X-planes. Like we've been spreading around to everyone to play nice with everyone. And now we wake up and we find that we're in a world where in the next 2 to 3 years, the Chinese are going to land on the moon. And what does that say about us when we've been trying to get back for a long time and spent over $100 billion to do it? So it's a concentration of our resources and a focus problem, certainly an empowerment of the workforce as well. I really believe there's a lot of things that you don't want to throw money at until you actually get it dialed in operationally. And that's kind of where we're at right now.
Very cool. Thank you.
Gotcha. You want to say?
Oh yeah, we got Elijah from Texas.
Hey, Elijah.
Hi, Elijah. All right, well, let's get him unmuted.
Hi. So first, I just want to say thank you so much for doing this. It means a whole lot to all of us. My
pleasure.
question is, the Copernican principle, which was popularized by J. Richard Gott, says that essentially, since we're experiencing what we are now, the future of space exploration is probably going to dwindle. And so I just wonder what your opinion on that is regarding public interest in the space program and kind of whether the future of it will keep people confined on Earth or whether we really will explore other galaxies and solar systems and stuff.
Well, I would agree that I do believe that it's somewhat cyclical, that, we're in a high right now after Artemis 2, but, clearly the attention that, Apollo 17 had was very different than when Neil and Buzz walked on the moon in Apollo 11. I think you got to keep it fresh. You got to keep pushing the boundaries and setting new, inspiring objectives, crewed and uncrewed, that maintain the public interest and keep momentum going, towards the direction the agency was established to pursue from the get-go. I think if you get comfortable, kind of in this with a lot of repetition in your missions, which nothing against the International Space Station, which is.
Uh-oh.
Did we lose him?
Jared!
No,
We're cutting out. No.
our main guy. Yeah.
Hello.
Yeah.
Oh,
Oh,
hi,
okay, gotcha.
Jared.
Got me?
You're back.
Yeah,
Back.
keep going.
Yeah, look, I'm just saying I agree with you. You got to keep things fresh, right? You need to continue to set inspiring goals, continue to push the limits, keep the public engaged. It's taxpayer funded. And if you don't, and people lose interest, that's how programs like Apollo get canceled and such. But we're on a high right now, and we're going to seize the momentum that we have today. Now, do I think that the risk of this cyclical nature puts at risk humanity's ability to expand beyond our home planet here at Earth? I mean, in worst case, it delays it. I think it's inevitable. Now, industry investing like extraordinary amounts of capital into trying to unlock a true orbital economy is everything. Because the moment, you take the whole argument of like, how can you invest in space because of all the hardships we have here on Earth? The moment you take that off the table and like it's somewhat economically self-sustaining, which we're reasonably at with launch observation and communications. But like, let's say we are mining something on the moon or asteroids, and like there is a massive economic potential unleashed from space. All that, cyclical nature of public attention off and on goes away because it's not being funded off the backs of taxpayers anymore. So that to me is inevitable that we'll extend our reach beyond Earth. But I do agree it's an obligation for anyone who's sitting in my seat and across industry to keep the momentum going.
Yeah, I think that's super interesting, like how public morale affects like what NASA does like as a whole. Super quick, is there anything like NASA has been doing or has done specifically to keep public interest and morale in mind to like increase like people's interest in it? Like I'm sure like obviously the astronauts go on like talk shows and things like that. What PR things does NASA do?
Well, I think, look, just focusing on the mission too, to be honest, like nothing's going to draw people's attention more than like four outstanding astronauts going around the moon. So, launching the missions that we are supposed to be doing, the ones they haven't seen in a long time, is a good way to spark the interest. And then I would say, honestly, a focus on quality over quantity. Not that long ago, like NASA had like 400 social channels. I mean, it was like an insane amount of them out there, every one of them putting content out. And it's like, we have the best material to work with in the universe. Like we can concentrate on this and deliver the high impact stuff that when you look at it, you're just blown away.
Right.
And we've been doing a lot more of that, I'd say, over the last year, instead of trying to flood you with everything where at some point it's like, I can't, separate some of the, the signal and noise here on this. And therefore I'm just going to tune out entirely. That's the worst case.
Well, speaking of, what is your favorite photo from either of the Artemis missions that have happened?
Oh, hands down. So it's our gift. It's like we call it these like presentos or lithos that we give to like other space agencies and world leaders. It's our gift presento. So it's my favorite one, and it's with the solar eclipse, and it has the solar panel of Artemis in it. And I just think it's such an amazing contrast between something that human hands built over years and what the universe created over 4.5 billion years.
Oh, that's incredible.
That's cool.
Our next question is from Francis, who's 17 and from Virginia.
Hi, Francis.
Hey.
Hi, Francis.
Hi. Thank you so much for having me. So I want to ask, my question is, as the NASA administrator, what does your day-to-day life look like? And if you don't mind expanding on it, on like maybe some of your subordinates, maybe what does their lives look like? Thank you.
We're all super busy and trying to make progress, and we understand like you can't let a problem that you could solve today go to tomorrow. So I would just say we all maximize the heck out of every day. I would say that since I've been confirmed, like I'm like every day is an 18-hour day for me, 7 days a week, and I'm loving every second of it. So it starts really early. And a lot of it is around keeping everybody, again, focused on ignition priorities, return to the moon, build the moon base, launch nuclear-powered spaceships, rebuild the X-plane portfolio, ensure that there is a future beyond the International Space Station, and launch more missions of science and discovery. Where are we at with all these things? Keep people very much focused on driving those outcomes constantly. You meet with stakeholders to keep them in line, because we want everybody excited about those priorities. And again, not ever going back to the try and make everybody happy. And that includes in our international partners too. Like we never go alone on these efforts, but work towards the goals that we're trying to achieve as quickly as we can. You try and do always some inspirational or outreach thing, because I think inspiring the next generation is just, it's just fundamental to what we're supposed to be doing at NASA. You're going out half my time is probably in DC and half my time is out at the centers where the people are doing a lot of the hard work. They're building the rockets, they're launching, they're doing all the testing and such. So, but I'd say everyone here, we're all in this together. Everybody who shows up to work at NASA every day, again, they want to change the world in air and space. And we got this opportunity. We got an opportunity for the first time to do what we are supposed to do and not what everybody tells us to do. And we're trying to make the absolute most of it and just sprint every day.
And just to clarify, what do you think that NASA is supposed to do?
I think it's exactly what we announced on Ignition. And it's what's in the National Space Policy again. I think in human exploration, we are to move beyond the International Space Station. That doesn't mean it goes away, but we've been there for a quarter of a century. Let's return to the moon. We've been gifted a moon, 3 to 4 days away for us to test out all of the things that we are going to need to be able to go to Mars someday. How can we not take advantage of it? Let's go from microgravity. We'll go to 1/6 gravity. We'll start working with lunar regolith. We'll build habitats. We'll cover habitats with regolith. We will pave landing pads for giant landers to come down. We'll build lots of rovers. We'll figure out what's the good surface comms, orbital comms, power, and of course, in situ resource manufacturing, work with the water ice on the south pole of the moon. Like that's like the natural extension for human exploration, for technology and development. What do we need 10 years from now? Even 5 years from now? That's where your nuclear power and propulsion is, your next generation suits, your next generation closed loop eclipse systems, X-planes. We have one. We should have dozens of them. Push the boundaries in air and space, blur the lines between in and out of atmosphere, radical airframe and propulsion designs. NASA should not be taking your taxpayer dollars to try and squeeze 3 or 4% more efficiency out of a 40-year-old turbine engine. That's what the companies should be doing. We should be figuring out how to take you higher and faster in the future. And then just, everybody loves Hubble, Nancy Grace Roman, James Webb. How do you build more of them faster and launch them with greater frequency so we can get after the secrets of the universe and just keep it narrow there, keep it focused. And you do that and all the inspiration is going to take care of itself, because people are going to witness things like Artemis 2, not every half century, but like every year minimum.
Wow.
Gotcha. Yeah, that's awesome. Our next question, if you want to say, Jackson.
Oh, Jackson from San Diego.
Who's 17 years old.
Hi, Jackson.
Hey, Jackson.
Can't beat the weather.
Hi, can you hear me now?
Loud and clear.
Okay. So I'm Jackson from sunny San Diego. For Stardance, I built a set of astrophotography tools based on my experience just taking photos of the night sky. But that said, with the increase in visible satellite constellations and terrestrial light pollutions, do you see preserving access to an unspoiled night sky as something NASA should actively protect? And if so, what practical steps could NASA take to help cause that?
And also, Jackson, if you could talk a little bit more about your project, that would be great.
Please, yeah. Because
it's so cool. Oh, yeah, he has to.
Sorry, I can't unmute myself. So Astrophotography Tools was an offline website I built that has a set of 10 or plus tools, things that can essentially bring an amateur with no experience in astrophotography to being able to capture photographs of the Milky Way, of Starfield at night, to give them experience of where to shoot, what to shoot, how to shoot with whatever equipment they have available, and then how to edit those photographs to experience the Milky Way, which is something I experienced about 3 years ago, and it completely changed my life. And so I want to spread that to others.
As you should. Look, that's awesome. Some of my closest friends are astrophotographers and astronomers, and I certainly recognize the challenge here. And look, I think NASA's job is also to help where we can apply some of our subject matter expertise to industry on how to be, good participants in the atmosphere above us in low Earth orbit, so as not to preclude a lot of the things that we want, that are good to do in this. And I would say things like some of the treatments that they put on some of their constellation satellites. I mean, you're obviously living this in the field more than I am. You'd have to tell me how much that has or hasn't helped. Same things, by the way, with discarding second stages by doing proper deorbit burns and keeping low Earth orbit as pristine as you possibly can, while not overly restricting progress. And that's a balance, right? I mean, it's same thing. And forgive me for using like probably an extremely lousy analogy, right? But like cell phone towers aren't pretty, telephone poles aren't pretty, power lines that go around aren't. But like you do have to always balance some needs of like what you are taking away from the environment around us in order to make life better for everybody as well. And I'd say a lot of things like the Starlink constellation, for example, no doubt, like connecting the disconnect, it's saved lives, right? It saves a lot of lives, and it does so on every natural disaster response. So how do we balance some of that progress without, taking away some of what's important for folks like in your community that are enjoying studying the night sky?
Well, and with something like the Starlink constellation, is there a way to re-engineer those satellites so that it doesn't create that effect, or is it just like, does it just come with the territory? Like if you're
No, that was
creating...
what I was asking about, the treatments that they've been putting on some of them. Do you know the answer to that, sir?
I don't know the answer.
I actually don't know. Sorry, I don't know either. If how effective the treatments are at preventing the light pollution. I do know that uh, like almost all the Starlink satellites are visible to the night sky, and even like suburban settings, you can see the Starlink satellites before you can see the stars. So they are very bright, I think.
Yeah. Again, you're going to be a lot closer to the implication of this. I just know that the constellations from 3 years ago, for example, are very different than the ones they've started launching the last year and a half. Where, I mean, at least when I've looked at side by side pictures, one is obviously much more apparent and picked up in the photography than the others. But I can't really comment much beyond that, other than it is always some balance, right? I mean, it's the same thing if you're, it's maybe not as, I think it's somewhat analogous, whether you're building a dam and the associated downstream implications of that versus having like a low emission power source from it, or again, or building power lines or telephone like that. None of those are pretty and abstract views, and I'm sure have various environmental implications, but there is usually good that comes with it as well. And but to the extent there's best practices, and organizations like SpaceX and Blue Origin and such, I know are extremely receptive to public feedback on how to do better.
That's really interesting. I think that is something
Thank
that's really
you.
important. Like, obviously like light pollution and everything. Okay, for our next segment, we're gonna do 5 questions in 5 minutes. You ready?
I'll try.
Okay, cool.
All right.
Our first question is from Aditya, who's 14 and from California.
Hello, Mr. Isaacman. Hello, Will and Megan. So a lot of people are scared of nuclear power because they think it's dangerous for like incidents like Chernobyl. But NASA is using it a lot for space missions. So, Mr. Isaacman, how do you convince people that nuclear power is safe, and why do we need it so badly to get to deep space?
Well, first of all, I think it's essential to meet terrestrial demand, and we've improved the technology substantially. Like I said, TRISOL fuel and such, where we use ceramics on very low enriched uranium, survive catastrophes without creating a lot of radioactive, associated radioactive issues. And then where we're sending it, we're putting it in space. There's plenty of radiation out there. It was already there. I mean, it's a great environment for you to be operating a nuclear reactor from a propulsion perspective. And I would say, look, if it's done right and responsibly, look at the nuclear Navy. I think Hyman Rickover set us on a course for very responsible use of nuclear power at sea and undersea. And look, if you want to go out and extend our reach in the universe, you want to be able to send a mission to Enceladus and bring it back, or a mission that can go to Europa and come back without having to refuel it. You got to be using nuclear power.
Yeah.
Gotcha. That's awesome. All right. Next question is Sakura, who's 13 from Ashburn. Can we get you unmuted?
Sakura. There we go.
Oh, hey, awesome.
So, hi. My question is, if you were mentoring a student who wants to work in NASA or something related to space travel one day, what's the first thing that you'll tell them to do?
If I was like mentoring a student?
Yeah.
Is that the question? And sorry, like what age, education level?
I'd say around high school.
I guess, I mean, first thing is there's just going to be however many career fields you thought would be applicable in aerospace. By the time you graduate, there'll probably be 10x that. So I would say try and learn about all of the emerging fields that will be in aerospace that could be of interest, and really pick one and just be passionate about it, and then follow all the natural stepping stones to that. So like a lot of people will be like, I meet interns all the time. We have classes that come in. I'm like, well, what brought you to Glenn? Or what brought you to Kennedy Space Center? It was like, well, it was the only one I could take because I really wanted to come to NASA. But my true passion is over at JPL or at JSC. And it's like, well, you need to find a way to get there. In order to really stand out, to differentiate yourself, to continue to move up and have a bigger and bigger impact across a career field, you have to be the best at it. And the only way you're going to ever be the best at it is you got to love it. You got to be passionate about it. So like right now you're at an optimal, like, like I love all of this, whether it's engineering or aerospace, and I want to do something in it. Great. Where's your, pick your specialization, and you got time. But really, a lot is changing fast over the next couple of years. Find that path, and then like where you're really going to be passionate about and love it every single day. And then look at all the logical stepping stones to get you to your destination. Find the internship that is so closely related to that field you want to be in. That's like the next step thereafter. So I guess that'd be my that age like advice.
Awesome.
Thank you so much.
All right, now we got Mark from Slovakia.
Who's 15 years old.
Hi, Mark.
Hey, Mark.
Mark. There we go.
Hi, can you hear me?
Yes, we can.
I had multiple questions, so I don't know which one was.
Pick your best one.
Pick
chosen,
one.
but
Pick the most awesome epic question.
Okay, so hi, Mr. Isaacman. Where is going to be? Sorry for my English. Where is the plutonium, or like the enriched element for the fission reactors for the lunar missions going to be sourced from? Because like for the missions like Voyager, it was sourced from lone cores of the nuclear bombs, and now I don't know if there's so many of them right now, but I've heard that it's really like rare to. It's just rare to find it somewhere. Where is it going to be sourced from?
I mean, couldn't have found a better time to ask the question. I was actually at one of our national labs earlier today, watching the manufacturing of plutonium-238, which is the isotope we use for our RTGs, MMRTGs, as a power source for, say, Dragonfly. I actually got to operate the 1960s robotic arms in the hot cells on where a lot of the work is done. And I have to say that, like, one of my takeaways, I mean, that generation of engineers from 40s, 50s, and 60s is unmatched. I mean, in the same way, like what they did back then with the slide rule, and I think about that, it's the same thing with the NASA engineers that time period. I mean, just unbelievable. I mean, what was able to be accomplished in that time frame. But in any case, I can tell you from today, firsthand account, we are making the radioisotopes necessary for RTGs, for RUs, for helping rovers and landers survive the lunar night on the moon. This is a high priority for us, as is fission power, because obviously the difference between the worlds of like 1 or 2 kilowatts versus eventually scaling up to hundreds of kilowatts is going to be a game changer for the type of missions we'll be able to undertake.
That's awesome.
Well, yeah, I mean, is it the same? Is it the same uranium you would be putting in a nuclear reactor anyways, or is it different somehow?
Yeah, so the type of what we would use for an RTG or a RU is very different. So that would be plutonium-238 or potentially americium. What we use in a fission reactor for like SR1 Freedom is going to be a very safe, low enriched uranium covered in in basically these ceramic pellets that are designed for like safe nuclear reactors. So totally different. Uranium is the go-to for our space-based nuclear reactors for nuclear power and propulsion, and then for RUs and RTGs it would be plutonium or americium.
Yeah, obviously, Will. Who doesn't know that?
I'm sorry. Yeah, I should have been more.
Our next question is from Aya, who's 15 from Morocco. Oh, never mind. I lied. It's Julia, who's 18 from Vermont.
Hello, can you hear me?
Loud and clear.
Cool. What's a belief that you held strongly 5 years ago and you've completely changed your mind about it, and why?
I would say I have become a bit more spiritual since I've been to space. I wouldn't classify myself as like a overly religious person, but I would say I think when you go to space and you have an opportunity to appreciate the scale of what's around you and the simple reality that you will run into dead ends where, the physics story ends and we don't have good answers, is thought-provoking. a great place to be is at NASA for that, where our goal is to try and, further understand the universe. But I would say, like, in terms of just overall beliefs, like, I would say having gone to space for sure, I would say I'm slightly more of a spiritual person than I was before.
That's really interesting. I think we've heard also the same thing from like the Artemis 2 astronauts, that they learned
Yeah.
like poetry and stuff so they could like express their feelings better, which I thought was like super interesting. Our next question is from Santiago, who's 16 from Mexico, and he showed us earlier like this incredible schematic and PCB that he made to improve like classic cars and their light system. So that's like super cool. But yeah.
That's awesome.
Hi, my name is Santiago. I'm from San Luis Potosí, Mexico. I'm a little bit nervous.
We all are.
I wanted
okay.
to ask something related to my project. My project is a BCM, a body control module, designed to give old cars modern features like automatic lighting and something like that. My question was, when moving from prototyping custom logic boards to aerospace engineering, what is the single most critical lesson about fault tolerance and hardware redundancy that you've seen engineers fail to grasp, both at SpaceX and NASA?
That's so
And
good. That's a good
whether you're leading private missions like Polaris Dawn or directing missions at NASA, building high-performing technical teams is critical. When you look at the engineers and developers who thrive in your projects, what specific mindset, problem-solving profile, or core skills do you look for that aren't usually taught in classrooms?
Whoa. Well, neither one of these are a 1 minute answer. Look,
I think the first question is probably more.
I would just,
sorry. Yeah, go ahead.
Yeah, I would just say, look, I think it's very different. You totally different problems, different, different constraints on like the engineers, I would say, come at NASA versus what I've seen at SpaceX. First of all, they're both brilliant and do incredible things. So I'm hardly in a position ever to be critical, more of observations. Let's just put it that way. I would say that, NASA, when we are looking at solving problems, we are trying to solve a lot of them at once. And as a result, we tend to, which is actually not how we did it in the 1960s, we jump right to the desired solution. So, doing the near impossible should be very hard. And you generally favor like an iterative
Hey,
approach.
Jared, so sorry to interrupt. Are we encroaching on your time? Do you have to go somewhere? Like is 5 p.m. like a
my
hard
team's
stop
saying
for
it's the last question, but I would just say, like at NASA, we tend to, we've of late jumped right to a dream state, which makes the problem that much harder on ourselves to engineer a solution to. And as a result, we tend to be late and over budget a lot. And I would say like SpaceX, a lot of philosophy, especially being part of a developmental program like Polaris, where we're building a suit, they're very focused on what is the single greatest obstacle in front of them to solve, learn from it, and then they'll focus on the next one. And there's a lot of, there's advantages and there's potentially weaknesses to both, and some where if you parallel path some things, it might help you get to the ultimate destination a little bit faster. But if you jump right to the ultimate destination, like we tended to do at times with NASA in more recent history, you're just biting off more than you can chew, and it becomes too big of an engineering problem to potentially solve. And I would say generally what's worked really well is what SpaceX has done, and because that was in a lot of ways similar to what NASA did in the 1960s, Mercury before Gemini, Gemini before Apollo, a lot of Apollo missions before Apollo 11. And look, there's a lot of qualities that are extremely important, I think, in whether it's engineers, scientists, technicians, that I think the openness to, continuous learning, that we never stop in this journey. And what we thought for sure was correct from in years past can be a very different environment today. And you don't want to close the door on potentially new avenues to pursue. And I think the willingness to learn, which maybe is another way of saying humility, is fantastic. The way I certainly value that and enjoy being around it. Extreme ownership. I think SpaceX does that extremely well too. But like when you take on a problem, you see it through. And you are responsible for the outcome, good or bad. And it's okay to make mistakes and fail as long as you learn from it. And that's and avoid repeating it. But those that don't take ownership or try and push off responsibility on others are doomed to continue to repeat those mistakes, and they're a liability and not an asset on a team.
Yeah,
hopefully
and
that's
I think
somewhat
that
helpful.
we will learn a lot about that from Hack Club as well. Like you have to take ownership and you have to make sure that taking charge and like taking agency. I think is a big thing here.
Yeah.
Well, thank you so much, Jared, for meeting with us and giving us your time. I mean, I cannot thank you much and as much as I can. And to the 536 people that are here and teenagers that look up to you, you cannot imagine how much this means to us. And yeah, we just thank you beyond what I can express.
Thank you so
This
much.
was awesome. I
yeah.
am so grateful to spend time with all of you. I mean, you guys are all the future. Look at you. The fact that you are getting after it from such a young age and building awesome hardware right now and learning, you're ahead of the curve, and you're exactly the kind of people that we're going to need to grow up and change the world again. I mean, you're going to be the ones contributing to whatever comes after the moon base, whether it's Mars or whatever's next in this grand journey that we're all on together. So grateful for your interest. Love the passion. Don't give it up for a minute.
Awesome. Well, thank you so much.
Thank you.
I don't know if your team is going to get mad at us. Do you have time for one more question from Zach, the Hack Club co-founder?
Sure.
Okay.
Is-
Okay, cool. That's right.
Here's Zach.
Okay.
Hey, Jared.
Hey, Zach, how you doing?
Good to see you again.
Good to see you too.
Thank you so much
Thanks
for
for doing
joining
this.
today. I mean, this is just incredible having you here, and just so inspiring what you're doing to bring us back to space. I have a question that we ask every guest who comes and does a Hack Club AMA, and the question is: when you walked into the NASA studio to get on this Zoom call, imagine if instead of clicking join and you're on the call, when you click join, you were suddenly, you don't know why or how, teleported back to the year 500 BC. And you realize, everyone in this world is treating you like dictator of the world. So it's at 500 BC, you're dictator of the world. And you also realize that in the year 2026, in 2,526 years from now, there's going to be a great war between three identical Earths, and only one Earth is going to survive. The question is, what would you do as dictator of the world in 500 BC to best increase your Earth's chance of survival? There's three constraints. The first is that you can assume you're not going to die of any horrible disease. You have the rest of your lifetime, but you only have your lifetime. You won't be alive for 2,000 years. You have to set your plans in motion. Secondly, you're dictator of the world. You can do anything you want, but who knows if you say something, if people on the other side of the world will hear it by the time you die, because it is 500 BC. And then the third constraint is that the war is inevitable. You can picture three Earths going to a black box, only one comes out. People can't move between the Earths. So what would you do to best increase your Earth's chance of survival?
I think starting with whether it's love or empathy, but you have to try and the most unified Earth, 5,000 years or so, or did you say 500 BC? Okay, so like 3,000 years, whatever in the future, the most unified planet that's being able to contribute its resources and its intelligence to solving the problems to ensure survival in this great conflict is going to be important. So from the earliest days possible, to try and have a unified global society is pretty important. So I'd say anything we could from a populace of love and empathy, I think would be pretty important to ensure we're less divided. Learning, right? I mean, a culture from education from the start of what little we know back then, and even in today, let alone 500 years in the future. I've often described when we talk about people, where are we at? What inning are we in? Or any other analogy to this great adventure we're on of exploring the universe. I'm like, well, we just figured out how to hollow out a log and float across a pond. That's where we're at right now. And that's in today's day and age, let alone hundreds of years in the future. So a culture, that craves knowledge, right? And never stops learning will hopefully set us up for some sort of technological advantage in years ahead. So, I guess love and empathy, a hunger for knowledge.
Beautiful.
And I would say, I guess it kind of goes hand in hand in that, but it's the curiosity as well. It's got to be a critical component to it, to not be afraid to cross the seas or climb the mountains. While we're here on Earth, is going to lead us probably to the technological breakthroughs that hopefully give us the edge when the Great War arrives. I don't know. Hopefully that those were good enough.
That's beautiful. Thank you so much.
Thank you so much, Jared.
So we have a tradition where we end every Hack Club call by all sticking our hands out, and we do 3, 2, 1, and count and shout hack. Would you like to lead us in the countdown today?
All right, let's do it. Okay,
All right.
everybody's ready? Standing by. 3, 2, 1.
Hack.
All right, take care, everyone.
Thank you so much. Have a great rest of your day.
Thank you.
Yeah, bye.
Yeah, and thanks everyone so much for joining. I mean, oh my God, what an inspiring call. And all your questions were just so cool too. Also, I'm sorry, can we give a hats off to our hosts, Will and Meghana? I mean, they were unbelievable.
No, pretty awesome.
Yeah.
But yeah, thank you guys. That was a pretty awesome call. You guys had some awesome questions. If you want to learn, like, hey, how do I get more involved in Hack Club? Like, how do I keep doing all these things and meet such like awesome people? Join the Hack Club Slack at hackclub.com/Slack. HACKCLUB, our t-shirts.com/Slack. That's where like all of our conversations happen. That's where we talk about new programs. That's where our new announcements happen. That's where, you can join the mailing list for cool stuff like the Jared Isaacman AMA. That's where you can join the channel called Meghana, which is where I am, and I'm super awesome. And so you should do that. And yeah.
Yeah.